Okay, so today we're going to look at completing the square. Last lesson we started to look at quadratic expressions, and we saw that there were really two different ways that we could write quadratics. We could write it in the normal way that we've seen traditionally, which is something x squared plus something x plus the constant on the end. But then we realised with a lot of quadratics, not all of them, but quite a few, we could factorise them. Okay, and these two different forms of the quadratic tell us different things. So the first form, if we look at the 4 on the end, if we set x equal to 0, we find y equals 4. So in this form, the equation tells us what the y-intercept is. Okay, when we have our other form, when we've put it into our two factors, when we have it in this form, we can set y equal to 0, and it actually tells us that x is minus 3, and when x is minus 1, it crosses the x-axis. So this form is really useful for that. So these two different forms have a different purpose, but we actually have a third form that we have to learn, and this is called the completing the square form. Okay, and we're going to look at what that is, but it looks like this. It looks like a constant, so a number times x minus a number squared plus the number on the end, which looks very confusing, but I'll explain how we get this. And I'm actually going to do this by using area, and we're going to use area to explain how we're going to turn a quadratic like this into something that looks like that. So let's have a quick look. So we've got a little rectangle over here on the left, and you can see it's got a length of x plus 2, and it's got a height of 2. And the area of this rectangle is going to be x squared and 2x. So the area is going to be x squared plus 2x. But I want to do something to this, and what I'm going to do is I'm going to chop this little bit in half here, and I'm going to move it to the top, and so it looks like the area on the right hand side. And because I've chopped this end in half, this distance here is 1, hence a distance of 1. And what I want to think now is, if I imagined this was a square, and I'm going to fill in that little top bit up there, the area of this square would be x plus 1 squared, because I've got a distance, I've got a width of x plus 1, I've got a height of x plus 1. But unfortunately, the area of this square is a little bit too big, because I don't want that little bit there. So what I have to do is I then have to subtract this area here. And in this case, I've got a 1 by 1, so I've got to take away 1 squared. And now these two things are equal to each other. So x squared plus 2x is equal to all of x plus 1 squared, take away this little extra area here, which is 1 squared. I'm going to do it with another one. So this time I've got a base of x plus 6 and a height of x. So my x squared and my 6x and my two areas. And just like I did before, I'm going to split this rectangle on the end in half, and I'm going to take this bit and I'm going to move it up here. So what have I got if I do the area of the square? Well, I've got x plus 3 squared. But just like before, unfortunately, that's given me this little bit of area too much. So I need to work out this and take it away. Well, if this is 3 and this is 3, I've got to take away 3 squared. And now these two areas are the same. So I've turned a quadratic from its normal form into its completed the square form. So let's look at the general case. So again, I've got x squared plus bx, which means this length here of the rectangle on the end must be a b, because I've got an x squared and I've got a b times an x. And just as I did before, I'm going to cut this in half and I'm going to move it up here. And then I've got the diagram on the right hand side. Now if I cut this in half, if all of this width here is b, then half of this width must be b divided by 2. Okay, so looking at the right hand side, the area of the square, again I'll draw the square going all the way around, the area of the square would be x plus b over 2, because that's what the dimension of the square is, squared. But as with before, we've got this little extra bit here which we need to take away, so I need to subtract b over 2 squared. Now that was quite complicated, okay, using the extra letter with the b does confuse things a little bit, so let's do a couple of examples. All right, so I want to put x squared plus 4x into its completed the square form. And what I do is I need to half this 4, because that was the little rectangular bit on the end. So I end up with x plus 2 squared, but then I've got to take away that small square in the top corner, so I've got to take away 2 squared. So we would write that as x plus 2 squared take away 4. And these two things are equivalent. Let's do the next one. Now we didn't do any takeaways graphically because it's a bit too complicated to, it's a bit more complicated to visualize, but it's the same process. I would have x minus 3 squared. Now this is where people can get a little bit mixed up. I've still got to take away that extra 3 squared. I'm going to prove this one because it's not as obvious. Let's expand that. If I expanded x minus 3 times x minus 3, I'd get x squared minus 3x minus 3x, and then because I do a minus 3 times a minus 3, I'd have plus 9. So that's why we always take away this extra little square in the corner, because I've then got to take away the 9 because this part is that, and then I'd have x squared minus 6x. Okay, right, I'm going to get rid of that because I don't really want it on the picture. So what is my answer? It's just x minus 3 squared take away 9. Right, so sometimes though we get a number on the end, we get a constant term on the end. But what we do is we actually ignore this part to begin with and we pretend it's not there, okay? And what I do is I complete my square on this. So if I just think about this, I'll do this bit in a different colour. I'd have x plus 4 squared take away 4 squared, because that's how I complete the square on this. But I've still got to write that plus 5 because I can't really ignore it forever. I can only ignore it while I'm doing my square part. So I've got x plus 4 squared minus 16. I'm going to keep the colour, plus 5. But actually now I can combine them together and tidy it up. And so my final answer is going to be x plus 4 squared. Well, what's minus 16 of 5? Minus 11. Okay. So I'll do one more. I think, oh, well, I'm not going to do this one. I'll leave that one. I think you can probably have a go. What I want to do is the ones where fractions get involved, because, again, we're just going to complete the square on this, and then we'll put the minus 1 on the end in a minute. So I've got x. I need to half this value. So it's going to be 5 over 2. Now, I know a lot of you are going to be really tempted to write 2.5 there, but please just write 5 over 2. So I've got in brackets x plus 5 over 2 squared, and then I need to take away this extra part, this 5 over 2 squared. And this is why we want fractions, because fractions are really great when you've got to do quite complicated things like this. Because I need to work out what 5 over 2 squared is. And as we know, anything outside a bracket acts on both things inside the bracket. So what we end up with is we've still got this x plus 5 over 2 squared. Take away, I need to square the 5 in the numerator and square the 2 in the denominator, and then I've still got that take away 1 on the end. So now I've got minus 25 over 4 take away 1, because I want to combine these two parts together. And let's think about that. So minus 25 over 4 take away 1 is the same as minus 25 over 4 take away 4 over 4, because 4 quarters is the same as a whole. So that becomes minus 29 over 4. So what am I left with? My x plus 5 over 2 squared minus 29 over 4. Okay, so let's get rid of that bit there. We'll do a last one and then you can have a go. So again, I'm just going to complete the square on this. I'm going to leave that bit on its own to begin with. So I've got x minus, so half of 9, I'm going to write as 9 over 2 squared minus my 9 over 2 squared. And I've got the take away 6 on the end. Let's simplify this. So I've got x minus 9 over 2 all squared. Right, so the numerator is going to be 9 squared, which is 81. The denominator is going to be 2 squared, which is 4. Take away. Right, let's work this out. 6 is the same as 24 quarters. So I'm left with x minus 9 over 2 squared minus 81 quarters. Take away 24 quarters is going to be minus 105 quarters. Okay, right. Here's 6 for you to have a go at. Do them, then press pause, and I will show you the solutions when you press play again. So 1 and 2, quite straightforward, okay, because when you halve 10 you get a whole number, when you halve 16 you get a whole number. Nice. 3 and 4, a little bit more complicated because fractions get involved, but again, fairly straightforward. And 5 and 6, a bit of a mixture really. So hopefully you're okay with them. Right, now this is the part that if you have done additional maths, you won't have come across before. So now we need to look at how we complete the squares on quadratics where the coefficient of x squared isn't 1. Okay, so for instance, the first example, which is 2x squared, and the second example where we've got minus x squared. So the coefficient of x squared is no longer 1. And the rule is really, we can only complete the squared when we've got a single x squared. So we have to change these first. And so what we actually have to do is we have to take out whatever the factor is. So in this case, because the coefficient of x squared is 2, we need to take out a factor of 2 first. So I need to bring a 2 outside the bracket and then factorise the rest of the quadratic. So if I take out a factor of 2, 2x squared just becomes x squared. Because remember, how do we think about this? This times this has to make this. So 2 times x squared has to make 2x squared. Plus, again, remember, 2 times the x term has to make 8x. So it's got to be 4x plus. And again, remember, 2 times the n term has to make 20. So it becomes 10. And now, the way I think about it is you've just got to keep that factor of 2 outside all the time. And now you just complete the square on the inside of the bracket. So I'm going to scroll up because I'm not really interested in that top one to begin with. So what have I got? I'm always going to keep this factor of 2 outside. And to change, I'm going to show you by changing the colours. The 2's always staying out. So now I'm going to complete the square on the inside of the bracket. So I'm going to have x plus 2 squared. But remember, that gives me that extra bit in the corner. So I need to take away that 2 squared. And then I've still got the add 10 on the end. Still keeping that 2 outside, so I'm not going to write anything, I'm just keeping it out there. I've got x plus 2 squared, take away 4, add 10. Let's do the next line. So again, that 2 factor of 2 is staying outside. I've got x plus 2 squared. Now I'm going to tidy up the minus 4, add 10, which makes plus 6. And now the last step is, we do now have to bring this factor of 2 that's outside this bracket back in. So how do I do it? I do 2 times this and 2 times this, because I've got to do the 2 multiplied by each term. So what I actually end up with then is 2 times x plus 2 squared. Can't take that 2 inside the bracket here. Be careful, that's a mistake some people make. Okay, I just want 2 lots of this. Plus 2 lots of 6 makes 12. Okay, so what will we do with this one where we've got a minus? I'll be honest, the first thing I tend to do is I tend to write it so that I always start with the x squared term, because it's easier to see. So I would write this first of all by just writing it as minus x squared minus 4x plus 15. So I'm just writing it the other way around. So it starts with an x squared and ends with the constant. So what factor am I going to have to take out so that in my bracket it starts as a positive x squared? Well, I'm going to have to take out a factor of minus 1. Because minus 1 multiplied by x squared would give me minus x squared. So next term, minus 1 times what gives me minus 4x? Well, that would have to be plus 4x. And this is the hardest one. This is the one most people get wrong. Minus 1 times what makes plus 15 would have to be minus 15, because a negative multiplied by a negative makes a positive. So now we go back to exactly what we did in the last example. I keep that outside and I complete my square on the inside of the bracket. So in this case, x plus 2 squared minus the 2 squared minus the 15. So I've still got that minus 1 outside the bracket. Here I've got x plus 2 all squared minus 4 minus 15. Again, keep that minus 1 outside the bracket all the way down. So you've got the x plus 2 all squared. Well, minus 4, take away 15 is minus 19. And this last step where you have to bring these two, the minus 1 back into the bracket, so you're effectively expanding the bracket. And what you end up with is minus x plus 2 squared, and minus 1 times minus 19 makes plus 19. Okay, right, I'll do another example, another 2 examples. I'm just going to try and do these quite quickly. So here I need to take out a factor of 3. So I've got x squared minus 5x. And now we're going to end up with a fraction on the end, because 3 times what makes 8? Bit complicated to think about that, but hopefully you can see if I did 3 times 8/3, think about multiplying fractions, times the tops, you'd have 24 over 3, and that would simplify to make 8, or better way of thinking about this is they would cancel. So 3 times 8/3 makes 8. Right, let's get rid of that bit then. So we end up with plus 8/3. Right, so keep the 3 outside and we do our completing the square on the inside. So we're going to have x minus 5 over 2 all squared. Take away that extra bit of 5 over 2 squared plus my 8/3. Fractions are getting quite tricky, but you've got calculators so you can deal with this. 3, remember, keep that 3 outside all the time. x minus 5 over 2 all squared. Right, now let's deal with this. 25 over 4 plus 8 thirds. Now I've got to admit, I haven't got my calculator to hand, so I'm just going to have to do this the old-fashioned way. So 8 thirds take away 25 quarters. So I'm going to have to times by 3, times by 3, times by 4, times by 4. My God, this is a blast from the past. 32 over 12 minus 75 over 12. So 75 take away 32 is 40 minus 43 over 12. I hope, unless I've made a mistake, and if I have, I apologise. But we've got x minus 5 over 2 all squared, take away 43 over 12. I'm going to get rid of all that now. I'm sure you'll all put it in your calculator. But final bit, we bring this back in and we end up with 3 lots of x minus 5 over 2 all squared, take away 3 times 43 over 12 is just going to be 43 over 4. Okay, and I'm not going to do the last one apart from to show you that the first thing I would do would be to write it starting with the x squared, and then I'd have to take out a factor of minus 2. So it would become x squared plus 3x. And again, the last term is the most complicated. But minus 2 times what would make plus 7 is going to be minus 7 over 2. Let's check that out. Minus 2 times minus 7 over 2. Well, again, negative times a negative makes a positive. And the 2's would cancel. So it would make plus 7. Okay. And then you would carry on. And you would just complete the square and then expand at the end. Okay? Right. Again, here's 3 for you to have a go at. Press pause and I'll show you solutions when you press play again. So, first one, take out a factor of 2. Number 2, we just take out a factor of 3. Fairly straightforward, them two. Okay. Next two, a little bit more complicated, okay, because you end up with fractions. But again, the first one, take out a factor of 4. The second one, take out that factor of 2. And the last part of the second one is there. And then the final two, again, write them with starting with the x squared term first, so that then you can see with number 5 you take out a factor of minus 1. So inside the bracket becomes x squared minus 4x minus 12. Hopefully you can see when you take out a negative factor, basically all the signs just change. They become the opposite signs. Okay, and then again with number 6, swap it around to write the x squared term first and then take out a factor of minus 2. Okay, so why do we use completed the square version? Okay, what does it tell us that the other form does not? All right, because as we've said, the x squared plus x plus the constant on the end tells us the y-intercept. The factorised version tells us the x-intercept. So what exactly does this one tell us? And actually this one tells us a very, very useful thing. And it's all because of the fact that this is a number that is squared. And if you think about any number, no matter what it is, when you square it, it always becomes positive. The only exception to that is 0. Because 0 squared stays as 0. Any other number, let's look, minus 20 squared is going to become 400. 100 squared is going to become 10,000. 0.5 squared is going to become 0.25. Minus 1/5 squared is going to become 1/25. Any number squared is always going to be either 0 or a positive value. So that means the smallest this can ever be is 0. It can never be smaller than 0. And so because the smallest this can ever be is 0, the smallest that this can be is 5, because you'd have 0 plus 5. Okay? The same is true for the one on the right hand side. Let's think about this. The smallest this could be is 0. So the smallest this could be is also 0, because what is 4 times 0 is 0, which means, final colour, the smallest this could be would be 0. Take away 6, which would be minus 6. So this number on the end tells us the smallest that the y value could ever be, which is a really useful thing because it's basically telling us where's the lowest point on our quadratic graph. So if I were to draw a quick quadratic graph, I would know that this one would never go below 5. So it's going to look up here or up here or up here. It's got to look like this. Okay? But it'd be nice to know whereabouts it would be. And in the other one, I would know the lowest value this could be would be minus 6. So again, my quadratic graph is going to look like this. The lowest it can ever go is to minus 6. So that's fantastic bit of information that it's telling us. But when is it at its lowest point? So the lowest point is y is equal to 5. But this happens when this is 0. So how do I make my x plus 3 equal 0? Well, that's true when x is minus 3. So this tells me my lowest point is at the value minus 3, 5. Let's look at this one. So again, the lowest point is when y is minus 6, because the end tells us the lowest y value. That happens when this is 0. So I want my x minus 2 to be 0. So it happens when x is 2. So again, for this quadratic on the right, my lowest point occurs at the value 2 minus 6. So if I wanted to draw these two quadratics, I could draw my axes. I know at the point minus 3, oops, not minus 5, sorry, minus 3, 5, that is the lowest point of my quadratic. So it's going to go, sorry, not a very good quadratic there, up there like that. Okay, and how would I find that point? Well, remember, how do we find the y-intercept? Just as a little aside up here, my y-intercept happens when x equals 0. So I've got 0 plus 3 squared plus 5. So I've got 0 plus 3 is 3. 3 squared is 9. So that would happen at 14. And there I've got my quadratic. Let's have a look at this one. So again, I know my lowest point happens at 2 minus 6. So there's the lowest point there. Let's do what I just did with the other one. My y-intercept happens when x is 0. So I would have 4 times 0 minus 2 squared, take away 6. Right. Minus 2 squared, minus 2 times minus 2 is 4. So I've got 4 lots of 4, take away 6. Well, 4 lots of 4 is 16, take away 6 makes 10. So I know it crosses when x equals 10. So actually, this one is going to be a really steep quadratic, okay? And I could work out where it crosses the x-axis by setting y equal to 0. And this is really quite a nice thing with the completed the square version. I've got my 4 times x minus 2 squared take away 6 equals 0. So I could add the 6. So I've got 4 times x minus 2 squared equals 6. Divide by the 4. So I've got my x minus 2 squared equals 6 over 4. Square root each side. Sorry, I'm going to have to go over here now. X minus 2 equals the square root. I'm going to tidy that up to be 3 over 2. Of 3 over 2. And it's going to be plus or minus, because remember in maths now we always have a plus and a minus. So my x is going to be 2 plus or minus the square root of 3 over 2. Sorry, that was a bit of an aside and it went a bit more complicated than I intended. But there we go. So we could actually work out those two values as well by putting those in our calculator. So let's find the minimum value of each of those by completing the square. I think you can have a go at that actually, so I'll let you do that. See if you can find the minimum point of each of them and then have a go. So I'll do it nice and quick. X minus 1 squared, take away the 1 squared plus 12. Got my x minus 1 squared minus 1 plus 12. X minus 1 squared plus 11. Okay, so my minimum point is when this is 0, so when x is 1, my minimum point is at 11. With this one, 3, take out the factor of 3 first. So I've got x squared minus 2x plus 8. Let's complete the square on the bit inside the bracket. Again, x minus 1. Got to take away the 1 squared plus the 8. Still keep that 3 outside that bracket. X minus 1 squared minus 1 plus 8 is going to be plus 7. And put the 3 back in. 3 bracket x minus 1 squared plus 21. So my minimum point, again, is when this is 0. So when x is 1, my minimum point is going to be at 21. Okay? So, really useful to do a sketch. All right, so let's go back to what we did last lesson, sketching quadratics. Let's find, right, so we want to know what the y-intercept is. So my y-intercept, I set x equal to 0, so my y is 7. Next bit, I want to know where it crosses the x-axis or the x-intercept. Y equals 0, so I get 0 equals x squared plus 2x plus 7. But when I try and factorise it, I can't get two numbers that multiply to make 7 and add to make 2, so it won't factorise. If I try to use my quadratic formula, I would end up with my calculator saying math error. Okay, so that means there are no solutions for this equation. There is no value of x that would mean x squared plus 2x plus 7 equals 0. So what does that mean? It means it does not cross the x-axis. Okay, so I've got 2 bits of information up to now. I know it crosses the y-intercept at 7, and I know it doesn't cross the x-axis. But I'm still a bit stuck as to how to draw this quadratic because, let's be honest, it could go like this, it could go like this, it could go like this, it could go like this. I have absolutely no idea where my quadratic is going to go. And this is where we complete the square. So I'm going to do this on the side. So I'm going to do it up here. So I've got x squared plus 2x plus 7. So again, it's going to become x plus 1 squared take away that extra 1 squared plus 7. So I've got x plus 1 squared minus 1 plus 7 is going to be plus 6. So my minimum point is going to be when this is 0. So when x is minus 1, this is my minimum point. So now I've got that extra bit of information that I need. I know when my x value is minus 1, my minimum value is there. So at least now I can draw a quadratic and have it on the right side of the y-axis and have it looking roughly correctly. So when a quadratic does not cross the x-axis, the only way you can draw a reasonable sketch is to find where it crosses the y-axis and complete the square to find where the minimum is. Okay, what I would like you to do now is have a sketch of that one for me, please. Okay, so again, let's find the y-intercept, or where it crosses the y-axis. So when x equals 0, should put y there, y equals 15. Okay, let's have a look, see if it factorizes. So let's say 0 equals 2x squared minus 6x plus 15. So remember, we multiply those together to get 30. So we need two numbers that multiply together to get 30 and add to get minus 6. Well, we've got 1, 32, 15, 3, 10. 4 doesn't go into it. 5 and 6. So it's not going to factorize. And if you put it in your quadratic formula, you also find that there are no solutions. So it doesn't cross the x-axis. So the final thing is to complete the square. So remember, take out this factor of 2. 2x squared minus 3x plus 15 over 2. So complete the square inside the bracket. X minus 3 over 2 squared. Take away that extra 3 over 2 squared plus 15 over 2. Keep this bracket outside all the way along while you're working everything out. X minus 3 over 2 squared. Right, so 3 squared is 9 and 2 squared is 4. Add 15 over 2. And again, I'm not going to put it in my calculator. I'm going to try and do it properly. So I've got minus 9 quarters plus, well, 15 over 2 is the same as 30 over 4. So that becomes 21 quarters. So I have two brackets, x minus 3 over 2 squared plus 21 over 4. And then expand the bracket out and you have 2 bracket x minus 3 over 2 squared plus 21 over 2, because that times that is 21 over 2. So my minimum point is when this is 0, so it's when x is 3 over 2. My minimum point is here, which is 21 over 2. So let's draw my sketch. Got my minimum point at 3 over 2 and 21 over 2. Where did it cross the y-axis again? It was cross the y-axis at 15. Well, 21 over 2 is 10.5, so I'm going to put 15 about there. And so I end up with a quadratic that looks like that. Okay, everyone, have a go at the worksheet that's in Edmodo, please.